Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us to the farthest horizon that human eyes and hearts can imagine. Together, we'll explore the edge of the universe, that mysterious place where light fades into silence and wonder stretches farther than space itself. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each of us drifting in our own little patch of night. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the edge of the universe together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Imagine standing under a night sky so clear that it feels infinite, a dark ocean scattered with small, patient lights. You tilt your head back, and the stars above seem frozen, calm, eternal. Yet everything you see is moving. Each star, each whisper of light, is already far older than it seems. Some of that light began its journey before there were trees, before there were oceans, before there was even Earth to stand upon. What we call now in the universe is really a collage of ancient moments arriving late. Every point of a light above you is a message from the past, and every look at the stars is a small act of time travel. Astronomers call this immense stretch of visibility the observable universe. It's everything from which light has had enough time to reach us since the birth of space and time, about 13.8 billion years ago. But here's where the story bends slightly. The universe has been expanding that entire time, stretching like taffy pulled by invisible hands. Because of that stretching, the distance to the farthest objects we can see today isn't 13.8 billion light years, but closer to 46.5 billion. That number doesn't roll easily off the tongue, but what it really means is that the universe has grown faster than light itself could cross it. Not because light has slowed, but because the very fabric it travels through keeps expanding beneath it. It's like trying to walk across a room while the floor itself keeps sliding apart beneath your feet. When you look out into space, you're really looking backward in time. The farther away something is, the older the light that reaches you. The glow of a nearby star may be a few years old. The shimmer of a distant galaxy might have left before the first humans ever lit a fire. And when we gaze at the faint whispering background of microwave radiation that fills the universe, we are seeing light that began its journey when the cosmos was only 380,000 years old. A mere newborn, cooling from the fever of its own creation. It's humbling to realize that we live inside a kind of cosmic bubble, a sphere of visibility defined not by walls, but by time. Beyond that sphere, light has not yet had the chance to reach us. The universe might continue endlessly beyond what we can see, or it might curve back on itself like the surface of a great sphere, so that if we travelled far enough, we'd end up back where we started. We simply don't know. Our visible cosmos, vast as it is, could be just a tiny island in an infinite ocean. But infinite is a word that resists imagination. Try picturing it. A sky that never ends. Galaxies stacked beyond galaxies until the mind can no longer hold them. The thought itself begins to dissolve, like trying to remember a dream that slips away the harder you reach for it. And yet, that's what we're part of. Every atom in your body was once part of that expanding sea of light. The iron in your blood was forged in stars that lived and died billions of years ago. The calcium in your bones was built from dust carried through interstellar clouds. You, right now, are built from memories of stars. If we could step back far enough to see the universe all at once, it wouldn't look like a flat picture of dots. It would resemble a vast sponge of glowing threads, clusters of galaxies woven together by gravity, forming an intricate web that stretches across space. Between those glowing threads lie enormous voids, cosmic rooms so empty they seem unfinished. From this distance, the universe looks delicate, a pattern drawn by invisible forces, always expanding, always reshaping itself. Sometimes people ask, where is the centre of all this? But the universe, it turns out, has no centre. The expansion of space happens everywhere at once, like rising dough filled with raisins. Every raisin seeing the others drift away, but no single one sitting at the middle of the rise. To ask where the edge or the centre lies is like asking where the edge of a dream begins. Even now, as we speak, that expansion continues. Galaxies far beyond our reach are moving away faster than light can catch them. They are vanishing not because they've changed, but because the universe is growing between us. The observable horizon, that shimmering limit of what we can see, isn't fixed. It's receding faster than we can chase it. Every night, the cosmos quietly hides more of itself beyond the reach of our sight. And yet, there's something oddly peaceful about that thought. The universe is not a closed book. It's an unfolding story that will never be finished, not even by the billions of eyes that will look up after us. Our role is simply to be here, to notice, to marvel at the light that does arrive, carrying the gentle voice of ancient stars. If you listen closely, maybe you can sense it now. The quiet hum of distance, the soft pulse of galaxies drifting apart. It's not a sound you can hear, but a rhythm you can feel, deep in the body, matching the slow beating of your heart. That same pulse runs through everything, through stars, through atoms, through the long fabric of time itself. As we drift further into the story, we'll explore what lies at the edge of this visible dome. The horizons that define what can and cannot be seen. They're not barriers of matter, but of time and motion. Curtains of light, drawn gently across the stage of the cosmos. And beyond them, something waits. Quiet, immense, and still unfolding. You and I are still standing beneath that same sky, though now the night feels deeper, as if we've taken one quiet step outward. The stars haven't changed, but perhaps your sense of distance has. You can almost feel the weight of time above you, layered and translucent, like veils of silk stretched across eternity. Astronomers call those veils horizons, the invisible boundaries that separate what we can know from what we can only imagine. The first of these boundaries is known as the particle horizon, though you don't need to remember the term. Think of it as the farthest photograph we can ever take of the past. Light has been travelling toward us since the universe was born, but it's only had so much time to reach our eyes. Beyond that limit, beyond the most distant glimmers our telescopes can catch, there may be countless galaxies still shining, yet their light has not had long enough to arrive. They exist, but for now, they live in silence. The edge of that silence marks our first horizon. It's as if the universe keeps a secret diary, and we've been allowed to read only the most recent pages. The earlier ones are still locked away, waiting for time itself to turn the next page. The second boundary is more subtle and perhaps more mysterious. It's called the event horizon, but you can imagine it as the promised line, a place beyond which no signal, no message, no ray of light we send will ever reach. Because the universe is expanding, there are regions so far away that by the time our light travels toward them, the fabric of space will have stretched even farther. It's like trying to catch a boat that's drifting downstream faster than you can swim. The harder you try, the farther it slips away. The event horizon isn't a wall in space. It's a moving threshold in time. The moment something crosses it, its story becomes unreachable to us forever. Then there's the third boundary, the Hubble horizon, named after the gentle astronomer who first noticed galaxies drifting apart like lanterns on a river. This one describes a more immediate limit, the distance where the flow of expansion itself pulls space faster than light can move through it. Nothing is breaking the laws of physics. Space simply carries those distant galaxies away as naturally as a current carries fallen leaves. Imagine standing on a bridge over a wide river. Close to you, the water moves slowly and you can follow each ripple. Farther out, the current quickens until it becomes a blur, and somewhere beyond, it vanishes from view entirely. That vanishing point is the Hubble horizon. Everything beyond it is still there, but forever hidden in the motion of the flow. If these three horizons sound complicated, try thinking of them as three curtains of light, each drawn across the universe at a different distance, each marking a different relationship between space, time, and our ability to see. The first curtain hides the past we can't yet reach. The second hides the future we can never touch. And the third marks the moment when space itself begins to outrun light. In a strange way, these horizons make the universe feel smaller, yet also more precious. They remind us that every photon of light, every faint speck of glow we can capture, is something rescued from that vast ocean of unreachability. When you look at a photograph from the Hubble Space Telescope showing thousands of galaxies in a single frame, remember that each of those galaxies might be one of the last we'll ever see. Many of them are already gone, their light only now arriving across billions of years, like postcards from travellers who have long since vanished beyond the horizon. It's easy to imagine these boundaries as cages, as if the universe were teasing us with glimpses of what we'll never touch. But the truth is gentler than that. Without these limits, we couldn't see anything at all. The horizons give shape to our view, the way fog gives shape to a valley. They turn infinity into something we can gaze upon without being blinded. And there's another kind of horizon too, not in the sky, but within us. The human mind has its own limit to what it can imagine. Try to picture 1 billion years, then 1 trillion, then 1,000 trillion. At some point the numbers blur into a soft haze. You can't quite see them anymore, but you can feel their immensity. That feeling, a mixture of awe and quiet surrender, is the closest thing we have to touching the infinite. Sometimes when astronomers talk about these scales, they use symbols and equations that look almost musical. The speed of light written as c, the stretching of space described in formulas like 1 divided by the Hubble constant. But underneath those numbers are simple truths that anyone can grasp. Light always moves at the same pace. Space, however, keeps changing the length of the road. The result is a universe where even the swiftest traveller can never see it all. If you imagine space-time as a great ocean, then light is a swimmer moving steadily through it. In calm waters, it reaches far. But when the current of expansion rises, it drifts backward, unable to reach the farther shores. Our telescopes, no matter how powerful, are like small boats sailing on that surface, catching only the waves that happen to roll in. And yet, those waves are enough to tell us a story. One of those stories began when light first broke free from matter, when the young universe became transparent. Before that moment, space was filled with a glowing fog, hot and crowded, where light couldn't travel freely. When the universe cooled, that fog thinned, and photons began their long journey outward. We still see them today as a faint afterglow that surrounds us from every direction. The cosmic background, the first dawn. It's the nearest thing we have to a photograph of creation itself. The existence of these horizons also means that the universe we see will keep changing. Every second, more galaxies slip beyond the outermost boundary, disappearing into the unreachable. Future astronomers, billions of years from now, might look at the sky and see only their own galaxy, floating in silence, unaware that there was once a time when the heavens were crowded. What we see today is a fleeting privilege, the universe in its blossoming youth, before the petals drift away. And yet this vanishing act is strangely comforting. It means the universe is alive, dynamic, in motion. We are not standing in a museum of frozen light, but in a living landscape that keeps breathing, expanding, evolving. Horizons move. They're not borders, but conversations between distance and time. If you close your eyes for a moment, you can almost feel that motion. A slow drift, gentle as a tide, carrying everything outward. The galaxies, the stars, even the atoms in your body are part of that same current. You are not separate from the expansion. You are moving with it, carried quietly on the same cosmic wind. The path now carries us toward the next layer of that story, to the ancient light that forms the boundary itself, the map of the first ripples that ever stirred in space-time. For within those ripples, faint as breath on glass, lies the memory of how everything began. If we follow the thread a little further, the story brings us to one of the most delicate relics of the cosmos, the light that has been travelling since the universe was still wrapped in its infancy. It is faint, older than any star, and yet it fills every direction you could possibly look. This is the cosmic microwave background, often shortened to 3 simple letters, but there's no need to whisper them like a code. Think of it instead as the afterglow of the first dawn, the universe's baby picture, taken when it was barely out of the cradle of creation. Long ago, around 380,000 years after the beginning, the universe was a hot fog of particles, a stormy sea of light and matter tangled together. Photons, those tiny packets of light, were trapped, bouncing endlessly from one particle to another, unable to travel freely. You could not have seen through that early universe even if you were standing inside it. It was radiant but blind to its own light. As the universe stretched and cooled, that fog began to thin. The particles slowed their frantic motion, and for the first time, light slipped free. That moment, that first sigh of transparency, is what we still see today as a dim, omnipresent glow washing over everything. If your eyes could see microwaves instead of visible light, the sky would never truly be dark. It would shimmer with a soft, uniform brightness, the cooled echo of a fire that once burned everywhere. Scientists have built instruments sensitive enough to hear this echo, turning it into a kind of cosmic song. When they map it, they find it's not perfectly smooth. It's gently freckled, marked with faint, warm and cool patches only a few millionths of a degree apart. Those tiny variations are the fingerprints of everything that would follow: galaxies, clusters, planets, and eventually you. It's almost poetic, isn't it? The entire story of structure, of life and thought and curiosity was written into the universe as small temperature ripples in a sea of ancient light. In the quietest corners of that map, matter was a little denser, gravity a little stronger. Over billions of years, those slight differences gathered into rivers of stars, woven into the grand filaments we now call the cosmic web. From one of those filaments, much later, a small star formed. Around it spun a planet that would one day learn to look back and trace its lineage all the way to that first whisper of brightness. You could imagine those faint ripples as the soft grain of an old photograph. Each speck carries the memory of the universe's first breath. Even though scientists express those ripples with terms like microkelvins and angular scales, words that belong in laboratories, what they really describe is texture, the universe's earliest heartbeat, recorded in light. It's like holding an ancient seashell and still hearing the rhythm of the tide that shaped it. This ancient light also carries clues about the invisible forces that shape the cosmos. When researchers studied its subtle patterns, they discovered that ordinary matter, the kind that makes up stars and people and clouds, accounts for only about 5% of everything. The rest, roughly 26%, is a form of unseen mass we call dark matter. It doesn't shine or absorb, it only tugs, sculpting the paths of galaxies. And filling most of the remaining space, almost 70% of the cosmic budget, is something even more elusive: dark energy, the quiet pressure that drives the universe to expand faster and faster. It's tempting to imagine dark energy as some kind of substance, but it's more like a mood in the fabric of space itself, a tendency to stretch. The more space there is, the more stretching it seems to want to do. It's the universe's own version of curiosity, always pushing outward, always asking what lies beyond its edge. When we translate those ideas into numbers, they sound cold, ratios, constants, percentages. But when you think about what they mean, they become strangely comforting. The stars and galaxies we can see are just the glowing foam on the surface of a much deeper ocean. Most of what exists is quiet and unseen, yet its presence holds everything together. It's a bit like breathing. You hardly notice the air around you, but without it, there could be no song, no heartbeat, no sound at all. The cosmic background tells us something else too, that the universe is astonishingly smooth, and yet delicately imperfect. The flatness of space, measured to within a few tenths of a percent, suggests that the cosmos has no sharp edges, no corners where reality folds back. It's stretched out evenly, like a drumhead tuned with impossible precision. But the small imperfections, the tiny ripples we spoke of, are what allow structure to exist at all. Without them, there would be no stars, no galaxies, no warmth. Perfection, it turns out, would have been sterile. Creation required a touch of unevenness, a little randomness to break the symmetry. You might picture those early ripples as small dimples in a calm pond. Over time, as gravity pulled matter together, those dimples deepened into valleys where galaxies could settle. What began as a gentle murmur became the architecture of everything. In that sense, we live inside the echo of a ripple. Sometimes, people wonder what the universe looked like before this afterglow appeared, before light could travel freely. In truth, it wasn't a scene the human eye could ever witness. It was more like sound than sight, a throbbing mixture of energy waves and pressure that filled the cosmos. Some physicists describe those conditions with long equations and dense symbols, but you can think of it more simply as the universe humming to itself, tuning the first notes of existence before the melody began. Even now, billions of years later, that ancient tune still surrounds us. Satellites like Planck and WMAP have listened carefully to it, decoding its rhythm into maps that span the entire sky. When scientists turn those maps into images, the result looks like a soft oval of swirling colour, reds and blues representing warmer and cooler spots. But behind that colour lies a quiet truth. Everything you see, every detail of those patterns, is a fossil of light older than any galaxy. If you close your eyes and imagine standing inside that early cosmos, it wouldn't feel hot anymore. The glow has cooled to just under 3 degrees above absolute zero, barely warmer than the vacuum of deep space. It's so faint that the human body emits more heat than the entire sky. Yet without it, we would never have known our own beginnings. The cosmic microwave background isn't just data on a chart. It's the universe's lullaby to itself, still playing after nearly 14 billion years. Each photon of that ancient glow is a survivor of the first moment the universe could see. Every time we point a telescope upward, we are not only looking out but also inward, into the memory of everything that ever was. From here, the story opens into something larger still, what these whispers of ancient light reveal about the unseen majority of the universe, the dark ingredients that shape its future and its fate. Our quiet exploration now turns to the voices that move through the universe in ways that light alone cannot. For most of history, humanity believed that sight was our only cosmic sense. We built our understanding of the heavens through what could reach our eyes: light reflected, light absorbed, light bent. But as our tools became more sensitive, we began to discover that the universe also speaks in subtler languages, carried not by brightness but by vibration, by whisper, by the faintest of movements. These are the other messengers, neutrinos and gravitational waves, travellers that slip through matter and time with almost no resistance, bringing stories from places even light cannot survive. Imagine, for a moment, the heart of a dying star. Inside, temperatures climb to billions of degrees, and pressure crushes atoms until even their cores collapse. In those final moments, before the outer layers explode outward in a blaze of colour, countless invisible particles are released. These are neutrinos, so small and elusive that billions of them are passing through your body right now without leaving a trace. They come from the sun, from ancient supernovas, from collisions that happened when the universe was young. If light is the storyteller of the cosmos, then neutrinos are the spies, slipping through every wall to bring us news from hidden rooms. To understand how ghostly they are, you don't need any equations. Just imagine this. If you built a wall of lead 1 light-year thick, a barrier so dense that not even X-rays could cross it, half the neutrinos that reached it would still pass straight through as if it were fog. They barely notice matter at all. That shyness makes them difficult to catch, but it also means they can escape from places light cannot. When a star collapses into a supernova, its light may take hours to break free, bouncing inside the hot gas. The neutrinos, on the other hand, slip out instantly, announcing the explosion long before any telescope sees it. In 1987, astronomers around the world detected a sudden rush of these ghostly particles from a distant galaxy in the Large Magellanic Cloud. Just a handful were caught by massive underground detectors, but that handful was enough. Hours later, telescopes saw the same star bloom and fade. It was proof that we had begun to hear the universe through another sense, not by light, but by presence. To catch these particles, scientists have built silent observatories deep beneath mountains or frozen into Antarctic ice. They fill them with pure water or clear crystals that flash faintly when a neutrino finally decides to interact. Each rare flash is a greeting from the depths of creation, a particle that may have travelled 100 million years, only to brush against a single atom for the first time. If you could stand in one of those underground caverns, it would feel less like a laboratory and more like a cathedral. Vast, dark, waiting for the smallest sign of life from the cosmos. But the universe has an even subtler messenger, one that doesn't move through space at all, but is the movement of space itself. These are gravitational waves, ripples in the fabric of reality. You can imagine them as the tremors that spread when something unimaginably heavy stirs. 2 black holes orbiting each other, 2 neutron stars colliding, or the violent birth of the universe itself. When these events occur, they stretch and compress the very distance between things. If you had a ruler 1 million kilometers long, a passing gravitational wave would make it alternately shorter and longer by less than the width of an atom. Tiny, yes, but powerful enough to shake the stars. The story of their discovery reads like quiet magic. For decades, physicists suspected they must exist, following from Einstein's vision that gravity is not a force pulling on objects but a bending of space and time. Yet the ripples were so faint that no one knew if they could ever be felt. Then, in 2015, 2 enormous detectors, each shaped like a giant L, with arms 4 kilometers long, picked up the same whisper only milliseconds apart. It was the aftershock of 2 black holes colliding more than 1 billion light-years away. The detectors, known together as LIGO, had done what once seemed impossible. They had heard the universe move. Think of the delicacy of that moment. A vibration smaller than a single proton, crossing cosmic distances, arrived on Earth and nudged a mirror just enough for a laser beam to notice. The signal lasted only a fraction of a second, a brief rising chirp, but within that chirp lay a story of 2 monsters spiraling toward each other, merging into one. When scientists translated the data into sound, it wasn't a roar or a crash, but a soft, ascending note, like the pluck of a cosmic harp string. It was the music of space itself. Since then, we have detected many such notes, collisions, mergers, cosmic dances, each one adding a new instrument to the symphony. Gravitational waves and neutrinos complement light, offering a more complete way to sense the universe. Together they form what some call multi-messenger astronomy, the idea that the cosmos speaks not in one language, but in several harmonizing voices. Light tells us what shines. Neutrinos tell us what burns inside. Gravitational waves tell us how space itself sways. These discoveries change more than our science. They change our sense of belonging. We once thought we were observers, standing apart from the universe. But these invisible messengers remind us that we are participants. The ripples that pass through galaxies pass through you as well. The particles that leave dying stars travel through your heart, your skin, your breath, without pause. The same gentle shiver of existence connects everything. Sometimes when you stand very still, you can almost sense it. The background hum of motion, not loud, not obvious, but present. It's in the steady beat of your pulse, in the vibration of sound that fills a quiet room. You are made of atoms forged in long-dead stars, yes, but you're also crossed by countless waves, carrying the memory of their deaths and their rebirths. Light may have given us the image of the universe, but these other messengers give it depth. They let us feel the cosmos, not only see it. They show us that space is not empty, but alive with unseen travelers, each carrying a tiny piece of truth. And when we listen carefully enough, their voices blend with our own. The same low-frequency hum that runs through every atom, every moment, every dream. The trail of clues leads us gently into the next question. What happens to this great cosmic music as the universe grows older? What does it sound like when the instruments begin to fade, when even light starts to tire? From here, the story opens into one of the most humbling questions in all of science. If the universe stretches in every direction, does it ever end? Or could it curve back upon itself, looping endlessly so that every traveller eventually returns to their starting point without ever finding an edge? It sounds simple at first, a child's question asked while looking up at the stars, yet the answer is as vast and uncertain as space itself. For most of history, people imagine the heavens as a kind of shell enclosing the Earth. The stars were thought to be tiny lights fixed on an enormous sphere, perhaps rotating like a celestial clock. Then telescopes revealed that the stars were suns, scattered throughout an unimaginable depth. And when Edwin Hubble showed that even though suns belonged to distant galaxies, moving away from one another, the illusion of a cosmic boundary dissolved. Space wasn't a dome, it was an ocean, expanding, restless, seemingly without shore. But infinity, as comforting as it sounds, brings its own puzzles. If space truly goes on forever, then somewhere out there, every possible arrangement of matter must repeat. Somewhere, there could be another you. Same thoughts, same heartbeat, separated by distances so enormous that even light would never bridge them. The idea is both dizzying and strangely intimate. It reminds us that infinity isn't a number, but a state of mind, the point where imagination runs out of breath. Scientists have tried to measure whether the universe might actually wrap around itself. The evidence we have suggests that, on the larger scale, space is astonishingly flat. Flat, in this sense, doesn't mean empty or two-dimensional. It means that if you were to draw a triangle between three distant galaxies, the angles would add up just as they do on a flat table, not as they would on the curved surface of a sphere. The precision of this flatness is almost eerie, within less than half of 1%. That's like laying a sheet of paper across a sphere the size of Earth and finding it perfectly smooth. If the universe is flat, does that mean it's infinite? Not necessarily. It could still be finite but unbounded, like the surface of a balloon, which has no edges but loops back upon itself. Imagine walking in a straight line on such a surface. You'd never hit a wall, but eventually you'd return to where you began. You'd have travelled endlessly without ever leaving home. This is one way the cosmos might be folded, a vast loop with no inside or outside. These shapes, spheres, saddles, loops, even twisting toruses like the surface of a donut, aren't just mathematical curiosities. They're ways the universe might hold itself together. If we could travel far enough, we might see our own galaxy from behind, its light having wrapped around the cosmos. We might gaze at our own reflection, billions of years younger. In this way, space could be both infinite and intimate, a hall of mirrors where every image eventually meets itself again. We sometimes imagine that beyond the universe lies something else, another space, another dimension waiting beyond a wall of stars. But the word beyond loses meaning here. The universe is not expanding into anything, it's the stretching of everything itself. Like a rising loaf of bread with raisins scattered through it, space expands between the raisins, not outward into a larger oven. Every raisin sees the others drift away, yet no single one sits at the centre of the rise. There is no outside, there is only more of inside. Even the notion of edge becomes difficult to define. When we talk about the edge of the observable universe, what we really mean is the limit of what light can reach us, not a border that surrounds all of existence. There might be endless regions beyond our horizon, still forming galaxies, still unfolding. Or there might be a grand curve, folding everything back in on itself like the petals of an unseen flower. Either way, our position within the universe is not at the centre, nor the end, but somewhere in between, a quiet middle where awareness blooms for a short time before fading again into the dark. To make sense of this, physicists use models with symbols that represent curvature and density, but the essence of those symbols is simple. Think of space as a fabric. If it's stretched just right, it lies flat. Too much energy packed inside it, and the fabric curves inward like a heavy weight pressing down. Too little energy, and it curves outward like a drumhead pulled too tight. The exact balance between these tendencies determines whether the universe will expand forever or someday fold back on itself. Our best measurements suggest we live in that delicate balance, a cosmos neither collapsing nor open-ended, but poised between the two like a tightrope walker suspended above infinity. What does it mean for something to be flat on the scale of the entire universe? It means that parallel lines never meet. It means that light, given enough time, travels endlessly without bending back. And yet, because space itself can stretch, the path of that light still changes. A photon leaving a distant galaxy today will travel for billions of years, crossing the shifting fabric of the cosmos. The expansion of space will carry it farther than it could ever travel on its own. That's why the farthest galaxies we see are not just distant in space. They're distant in time, frozen in their own ancient chapters. Sometimes scientists talk about cosmic topology, a way of describing the possible shapes of the universe. They search for repeating patterns in the cosmic microwave background. Faint echoes that might reveal if light has wrapped around space and returned from the other side. So far, the pattern appears continuous, endless, but that might only mean the universe is larger than our visible patch. It could still curve back on itself beyond what we can see, just as the horizon of Earth looks flat to anyone standing on it, even though we know the planet is round. When you think about it this way, the universe becomes less like a flat sheet and more like a boundless landscape. If you keep walking, you may never reach an edge, not because there isn't one, but because the path itself keeps unfolding under your feet. Infinity, in that sense, is not something to be measured. It's something to be experienced. The feeling of knowing there will always be more. The philosopher might say that we need edges to define meaning, but the cosmos seems content without them. It flows in all directions, endlessly composing and recomposing itself. Every point is as valid as any other. Even your small place beneath the stars is part of the grand geometry, a brief moment of awareness within a shape too vast to ever complete. As you breathe in and out, you echo the rhythm of the universe itself, expansion and contraction, curiosity and calm. Maybe that's why thinking about infinity doesn't frighten us as much as it should. Deep down, we already understand that everything infinite begins as something small, a heartbeat, a spark, a thought. The same quiet balance that holds galaxies apart also holds you together. As we drift further into the story, we'll begin to see how this balance evolves over time, how the same gentle forces that stretch the cosmos also guide it towards stillness, and how the far future of the universe may not be a collapse or explosion, but a deep and graceful fading into calm. The path now carries us toward time itself, not the time that lives on your wrist or glows softly on a digital screen, but the time that moves silently through the stars. In our everyday world, time feels like a sequence of small steps, measured by seconds and hours. But on the scale of the universe, time unfolds more like a vast ocean current, slow and ceaseless. Every galaxy drifting away from another is a quiet tick in that cosmic clock, a reminder that motion and time are two sides of the same whisper. If you could stand outside the Milky Way, watching its spiral arms turn, you would see the seconds of the universe passing not by hands on a dial, but by the gentle recession of light. Each galaxy sliding away from its neighbour marks another note in a rhythm that has played since the first spark of creation. The cosmos doesn't measure time the way we do. It is time unfolding through expansion. Every distance that grows larger, every wavelength of light stretched longer by that expansion, is a reminder that the clock never truly stops. Right now, in this present era, the universe is in its golden afternoon. The stars still burn, the galaxies still form new suns, great spirals of dust still glow with the birth of light. The energy left over from the Big Bang still hums faintly in the background, like a memory of dawn. Life, at least here on Earth, has found a way to wake up and wonder where it came from. You're alive at a very rare moment in the cosmic story, when the universe is neither too young and violent, nor too old and still. It's as if you've arrived at the perfect pause in an infinite symphony, just as the music opens its most beautiful chord. But even beautiful chords fade. Look up at the stars and realize every one of them is burning its way through a finite supply of fuel. They shine only because they are consuming themselves. Hydrogen turns to helium in their cores, a slow alchemy of light that cannot last forever. One by one, across the ages, those lights will go out, not in violence, but in completion. Every star is a candle, and every candle, no matter how bright, eventually meets the moment when the wax is gone. Time in the universe does not rush. It doesn't care for the urgency of human years. The sun, for instance, is only halfway through its long journey. It has been shining for about 4.5 billion years, and it will shine for nearly 5 billion more. To the cosmos, that's just a breath, but to us, it feels like eternity. The sun's energy comes from the steady transformation of matter into light, the same quiet process that has shaped every corner of the universe. Inside its core, atoms fuse together, not in the harsh language of equations, but in the simplest story of transformation. Smaller things joining to become something new, something radiant. When scientists describe this, they speak of reactions that turn hydrogen into helium, releasing energy as light and heat. But you can think of it more tenderly. Deep inside that glowing sphere, the tiniest particles are learning to let go, to merge, to create warmth, to become something larger than themselves. That warmth travels outward, touching the face of the earth, falling across oceans, forests, and quiet windowsills. In that light, flowers open, rivers flow, and hearts keep time. Every second you live is powered by something that began in the heart of a star. The galaxies beyond us are following their own rhythms. They spin like wheels within wheels, each one a cluster of hundreds of billions of suns. Between them, the space continues to stretch. Imagine dots on a balloon as it inflates. None of the dots move across the surface, yet they all drift farther apart. That is the shape of cosmic time. Not the movement of things through space, but the expansion of space itself. Light travelling through this stretching fabric is elongated, its colour sliding gently toward red. Astronomers call it redshift, but you can think of it as the universe breathing out, exhaling light into longer, slower waves. If you could translate that expansion into sound, it would be like a note lowering in pitch, a hum deepening as the universe ages. The tone changes, but the song continues. That hum has been steady since the first galaxies formed. It's the sound of a clock that never stops ticking, because its ticks are made of motion itself. Everywhere you look, time reveals itself through change. Mountains rise and crumble, stars flare and fade, galaxies collide and merge like waves blending into one another, and yet in the grand scheme all of it happens slowly, gracefully. The universe doesn't hurry, it has no reason to. Time for the cosmos is an artist with infinite patience. There's a quiet comfort in knowing that. When you look up tonight and see the stars exactly where they were yesterday, it might seem as if nothing changes. But the truth is, everything is always changing, just too slowly for us to feel. The sun is losing mass every second as it sheds light into space. The Earth is gradually drifting farther from it by a small distance every year as the dance between gravity and momentum plays out. Galaxies continue to drift apart, stretched by invisible hands. The scale is so large that the motion looks like stillness. Our human minds are built for moments, not millennia. We measure time by the rising and setting of the sun, by the rhythm of our own hearts, but the cosmic clock measures in ages, in billions of years, in pulses of creation and decay. And yet, these two clocks are connected. Every tick of your heart, every breath you take, echoes the same principle as the stars: energy transforming, moving, radiating. In that way, you are part of the same flow that carries galaxies through space. You are time, noticing itself. One day, long after we're gone, long after Earth itself is gone, this same clock will still be ticking. The galaxies will be farther apart, their light fainter. New stars will form more rarely. The universe's pulse will slow, but it will not stop. In the far future, when the last star shines and fades, time will still move quietly through whatever remains. It is not bound to brightness. Time doesn't depend on warmth or motion. It simply continues, the silent current beneath everything that exists. So tonight, as you listen to the soft ticking of your own pulse, imagine that it's keeping time with the galaxies. Every heartbeat, every second of breath is part of a rhythm that began almost 14 billion years ago and will continue long after the last ember fades. The universe is a clock without hands, its gears made of stars, its seconds made of motion, its face too vast to see all at once. It never needs to be wound, it never needs to stop. And as we drift further into this cosmic symphony, we'll follow one of those small but faithful gears, our own sun, as it begins its slow journey toward twilight, reminding us that even the brightest flames eventually rest. The trail of light that brought us here now leads towards something closer to home, the story of our own star. The sun, warm and ordinary and taken for granted on so many mornings, is one of the most faithful companions Earth has ever known. It has watched the first oceans form, the first creatures crawl, the first eyes open to its brightness. It rises and falls each day with such regularity that it's easy to forget it is alive in its own way. A vast sphere of fusion, breathing in the language of atoms, but even the most patient flame eventually changes, and our sun is no exception. The sun began as a cloud, drifting quietly in a larger swirl of gas and dust left behind by long-dead stars. Gravity pulled that cloud inward, tighter and tighter, until its heart grew hot enough to ignite. From that moment, it joined the family of main sequence stars, the long-lived middle children of the universe. For billions of years, it has been content to fuse hydrogen into helium at its core, converting a tiny portion of its mass into the light that sustains life here. You don't need to think of the physics as equations. It's easier to picture it as a steady rhythm, the heartbeat of a giant. Every beat releases warmth, every beat keeps darkness at bay. Right now, the sun is remarkably stable, but it is also changing. Deep inside, hydrogen, the lightest and simplest element, is being used up, transformed into heavier helium. That process is slow. It will take roughly another 5 billion years before the balance tips and the sun begins to shift. When that day arrives, it won't explode or collapse suddenly. It will swell. The outer layers will expand, glowing red and wide, while the core shrinks and grows hotter. The sun will become what astronomers call a red giant. Not fierce, but enormous and soft-edged, like a paper lantern filling the sky. To us, from Earth's perspective, that change would be both breathtaking and final. The sun's swollen brightness would turn our blue planet into something strange and unrecognizable. Oceans would boil away, rocks would glow with heat, and the air itself would fade into space. But this isn't a story meant to frighten. It's a story of transformation, as natural as the fall of autumn leaves. The sun's expansion will be its way of returning energy back to the cosmos, releasing what it has held for so long. In its later years, the sun's gentle outer layers will drift away into space, forming a thin cloud of glowing gas, what we call a planetary nebula. It's an odd name because it has nothing to do with planets. It's simply the luminous shell a star leaves behind, lit from within by the fading core. You could think of it as the star's afterimage, still shimmering long after the light itself has gone. If you've ever seen pictures of the Helix Nebula, or the Cat's Eye Nebula, with their ghostly rings and glowing centres, that is what our sun may one day become. A final, fragile bloom in the garden of the sky. At the centre of that nebula will remain a small, dense core, a white dwarf. Though no larger than Earth, it will contain nearly half the sun's original mass. Its gravity will be immense. A teaspoon of its matter would weigh as much as a mountain. Yet despite its density, it will no longer burn. It will simply glow from the leftover heat of its long life, fading slowly over billions of years. Eventually, when it cools entirely, it will become invisible, a black dwarf, cold and dark, a relic of a once luminous heart. No explosion will announce its passing. It will just drift quietly into the soft anonymity of space. When we think about this far future, it's easy to feel small or sad, but there's another way to see it. The sun's death will not be an end, but a return. The material it sheds, the carbon, oxygen, and other elements, will seed new clouds of gas. From those clouds, other stars will form, and perhaps other worlds. In that sense, the sun will not vanish. It will simply become part of something new. Its atoms will continue their journey, scattered into the galaxy, woven into new beginnings. Somewhere, long after we're gone, a different planet may rise under a light that was once part of our own. It's humbling to remember that this cycle is universal. All stars age. Some, much larger than our sun, burn more fiercely and die more dramatically. They end their lives as supernovas, scattering heavy elements across the cosmos or collapsing into black holes, regions where even light cannot escape. Others, smaller and fainter, fade more quietly, slipping into darkness without fanfare. But in every case, the pattern is the same: birth from dust, a long radiance, and then a graceful surrender. The universe doesn't waste, it recycles. Even in death, stars give back the materials for new stars. new worlds, and the possibility of life. If you think about it, we are part of that same story. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was forged inside ancient stars that lived and died before our sun was even born. You carry within you the remnants of countless stellar generations. When the sun finally joins that lineage, its gift will continue. The light that nourishes you now will one day nourish someone or something else, somewhere beyond imagination. There's a quiet symmetry in that idea. Stars and people share a kind of kinship. Both burn with energy that cannot last forever. Both change as they age. Both, in their own way, shine because they're giving something away. When a star burns hydrogen, it transforms mass into light. When you breathe, think, create, or love, you transform energy into meaning. Each act, however small, is a contribution to the same luminous story. It helps to remember that endings in the universe are not abrupt. They unfold slowly, with grace. The sun will take billions of years to fade. Its light will linger in reflections, in echoes, in the atoms it leaves behind. Even when it is gone, the record of its existence will remain written across the cosmos, in the elements of new stars, in the chemistry of faraway planets, in the faint afterglow of everything it once warmed. So tonight, when you see the sun set and the first stars appear, you're watching both beginnings and endings at once. The twilight you see is ancient sunlight, scattered and softened by the air, a reminder that every glow carries a memory. Our sun is one of hundreds of billions in the Milky Way, each at its own point in the long arc from birth to quietness. To witness even a single one is to see a part of eternity. The path now carries us beyond this personal flame and out into the wider night, to the age when all stars, not just ours, begin to dim. For what happens to the universe when the last generation of suns grows old and no new fires take their place? If we follow the thread a little further, the warmth of our sun fades into the collective hush of billions of others. The galaxy, once a glittering spiral of light, begins to soften, like embers in a fire that has burned through the night. Star formation slows. The great clouds of gas that once gave birth to suns are exhausted, their raw material spent. What remains are the aging stars themselves, the last luminous heart still beating in an expanding sea of darkness. Astronomers sometimes call this distant time the degenerate era, though the term sounds harsher than it is. You could think of it more gently, as the age of dusk, a night when no new candles are lit and only the remaining ones continue to glow. It will not come soon. It lies perhaps 100 trillion years ahead, a number so large that the human mind can only touch it by metaphor. Imagine counting every grain of sand on every beach of Earth, and then repeating the count 1,000 times. That is the measure of time the universe has before its starlight begins to fade. In those years, the Milky Way will have changed beyond recognition. Long before the last stars fade, our galaxy and the Andromeda Galaxy will drift together and merge, their arms entwining in a slow cosmic waltz. The two will become one, a vast, smooth oval of stars known as an elliptical galaxy. Within it, millions of suns will still shine, but they will do so in quieter neighbourhoods, more spread out, each one further from the next. The skies of whatever worlds remain will be darker, more subdued, their constellations sparse. Life, if it still exists anywhere, will need to adapt to new rhythms. Without the birth of young stars, fewer planets will form. The universe will settle into a long reflective calm. The big acts of creation will be over, and what remains will be the slow afterglow. Not a death, but a deep rest. Most of the surviving stars in that age will be small red dwarfs, the humblest of suns. Unlike our bright yellow sun, these faint stars burn their fuel slowly, sipping it instead of devouring it. Some of them may live for 10 trillion years, longer than any galaxy has yet existed. When they finally run out of fuel, they will cool gently, turning from red to brown to black, leaving behind silent remnants that no longer shine. The larger stars will already be gone by then. The blue giants, the white-hot titans that once filled space with fierce brilliance, will have long since exploded, scattering their ashes into the void. Their remnants, neutron stars and black holes, will remain invisible but enduring. The universe will become a gallery of ghosts, collapsed cores, dark orbs, cooling embers. If we could watch it happen, it wouldn't be sudden. The dimming of the cosmos is like a sunset drawn out over eternity. Light fades slowly, star by star, until the background between galaxies deepens into near-total night. Even the Milky Way, or whatever name future beings might give to its merged descendant, will eventually vanish from sight to observers far away. The expansion of space will carry each island of stars farther apart until their light can no longer bridge the growing distance. The universe, once so bright, will become a scatter of isolated oases adrift in infinite dark. Yet even then, there will be a kind of beauty. Imagine standing on a distant world orbiting one of the last red dwarfs. The sky would be unlike any we know. The light would be faint, tinted crimson, soft enough to never cast a harsh shadow. The stars that remain would appear far apart, like scattered coals glowing on the edge of vision. Night and day would blend, and time itself would seem slower. Perhaps life, if it endures, would learn to live more quietly too, matching the rhythm of its fading star. Over unimaginable spans of time, the last white dwarfs, the stellar remnants like the one our sun will someday become, will continue to cool. Their surfaces will go from bright white to dull grey to invisible black. Once they cool completely, they will become what astronomers call black dwarfs, objects that no longer radiate light, only gravity. They will drift through space silently, holding in their cores the final record of their long existence. But the story doesn't end there. The universe is not still, even in darkness. Gravity continues its quiet work. Some of these dark remnants will drift close enough to merge, sending out small, soft ripples through the fabric of space, gravitational waves that travel forever. Others will fall into the deep wells of black holes, adding their faint mass to those eternal shadows. The process is slow, almost meditative. Nothing is wasted. Everything finds a place. Time itself in this era takes on a different meaning. To speak of years or centuries makes little sense when the smallest events unfold over spans longer than the age of our current cosmos. Mountains on any remaining worlds will crumble molecule by molecule. Orbits will shift almost imperceptibly. Even atoms may begin to tremble with age as the forces that bind them start to loosen. And yet, for all its melancholy, this vision of the future is not bleak. It is peaceful. The universe, once young and full of fire, is settling into a deep, dreamlike rest. The silence that follows creation is not nothingness. It is the pause between heartbeats, the breath between verses of an endless song. The darkness will not feel empty. It will feel vast, complete, patient. If you could stand outside of time and watch it all, the first stars igniting, the galaxies spinning, the last embers fading, you might see that there is no sadness in the cycle, only continuity. Energy becomes matter. Matter becomes light, and light returns to silence. Each phase gives meaning to the next. We, living in the bright middle of this story, are the brief spark between the dawn and the dusk. The night of stars will come, yes, but it will come gently. The universe has never been in a hurry. It will dim itself the way the sun sets over an ocean, slowly, gracefully, with colour that lingers long after the source has slipped below the horizon. And in that long twilight, the cosmos will still hum with the faint echo of what once was, a quiet testament to every star that ever burned. As we drift further into this story, the light grows thinner and the materials of existence themselves begin to change. For even when the stars are gone, the particles that made them still remain, waiting, restless, uncertain of what comes next. The trail of fading starlight leads us now into a deeper quiet, an age when even the faintest embers have cooled, and the universe, vast and patient, begins to loosen its own threads. The great play of creation and light that once filled the cosmos gives way to stillness. What remains is matter itself, waiting in the long shadow of eternity. Yet even here, the story continues, not with bursts of brilliance, but with the slowest transformations imaginable, the unravelling of the smallest things. In this distant future, the universe will be filled with the remnants of what once was. Darkened stars, drifting planets, black holes, and cold gas spread thin across expanding space. The distances between these remnants will be immense, growing larger as the fabric of space continues to stretch. The galaxies that once filled the heavens will be separated by gulfs so wide that light can no longer cross them. What remains of each will live in solitude, carrying within it the memory of a brighter time. It's hard to imagine motion in such a setting. The universe seems frozen, but deep within those dark remnants, subtle processes still unfold. Even the most stable things are not truly eternal. The atoms that make up matter, the tiny building blocks of everything, are bound together by forces that may someday fail. Physicists call this slow transformation proton decay. It means that the particles at the heart of atoms could one day dissolve into lighter, ghost-like forms, releasing the last traces of energy in the cosmos. You don't need to picture the equations or the numbers. Just imagine a rock, sitting in perfect darkness for longer than all of human history, quietly fading atom by atom into nothing that can shine. It is not destruction but return, the universe letting go of the structures it once held so tightly. If this decay truly happens, it will be staggeringly slow. A single proton might take 10,000 trillion years to vanish, a span so long that the number itself becomes meaningless. Yet across the endless canvas of time, even that slow process would be enough. Matter, given enough patience, would dissolve into energy, leaving behind a thin mist of faint radiation drifting through the cold. And so, after the twilight of stars comes a deeper night, not empty, but full of particles whispering their last stories into space. The energy of motion and light, once concentrated in stars and galaxies, will now be evenly spread everywhere. No warmth here, no brightness, just equilibrium, a perfect calm. This is what scientists call maximum entropy. But you might think of it as the universe reaching complete peace. Nothing more happens because everything has already found its place. But there is another possibility, one more mysterious and sudden, a quiet ending that might come without warning. Some physicists imagine that the vacuum of space, the emptiness itself, is not truly stable. They suggest that what we call nothing might hide a deeper state, one even more balanced than our own. If that is true, then one day, somewhere, a small region could shift into that deeper form, a bubble of new vacuum forming spontaneously. It would expand at the speed of light, rewriting the laws of physics as it went, changing every particle, every constant, every rule that shapes reality. No sound, no flash, just transformation. To think about that is to face one of the strangest kinds of beauty. The idea that existence could change in an instant and we would never feel it happen. The universe would continue, but everything in it would be remade in silence. Some call this vacuum decay, but the name doesn't capture the grace of it. It's not decay like rot or ruin. It's more like the soft exhale after a long-held breath. The cosmos releasing itself from tension. It's easy to think of such an ending as tragic, but perhaps it's only natural. Everything that begins eventually seeks stillness. A star burns and then rests. A wave rises and falls. Even the universe, after its long expansion, may simply wish to stop moving. In that sense, entropy is not an enemy, but an arrival. It's the settling of the cosmic dust after an impossibly long day. When the energy of the universe spreads so evenly that nothing new can happen, time itself may lose its meaning. Time, after all, depends on change, on the difference between before and after. In a universe where every part is the same temperature, the same emptiness, there would be no before to speak of. The clock would still exist, but its hands would no longer move. That state is sometimes called heat death, though the name feels too harsh for something so serene. It's less a death than a final rest, the still surface of an ocean at absolute calm. You might wonder whether anything could survive such an ending. Could thought, or memory, or spirit find a place to exist when the universe itself has gone quiet? It's a haunting question, but it may not need an answer, because even if everything fades, the act of existing, the long story of motion, of warmth, of awareness, will have already happened. The cosmos will have dreamed its dream, and that may be enough. In this silence, perhaps time itself will begin to blur, to dissolve. Without light or change, seconds and centuries will merge. The universe may no longer count its own moments, it will simply be. The poet might say that the universe is exhaling its last truth, the final note of a song that began as a bang and ends as a sigh. From heat to cold, from structure to stillness, from motion to peace, it has come full circle. There is a strange grace in imagining that everything we know and love, all the colours, all the warmth, all the chaos, will one day rest in perfect equilibrium. If we could listen to the end of time, it wouldn't sound like a crash or a cry. It would sound like a deep, fading heartbeat, slowing until the pause between beats stretches into forever. The universe would not be gone. It would simply have become so vast and even that it no longer needs to move. It would rest, a canvas without a painter, but still beautiful in its quietness. And yet, even here, in this imagined stillness, the story refuses to end completely. Because endings are only edges, and edges invite curiosity. The calm after the unravelling might be only one side of the cycle, a pause before a new motion begins, a quiet before another dawn. From here, our quiet exploration turns toward that possibility, that the end of time may not be an ending at all, but the opening of another beginning. The path now carries us beyond silence, past the last trembling of matter, into a realm where even time itself begins to lose its shape. Up to now, the universe has been a motion, an unfolding. But what happens when motion ends? When every particle, every wave, every whisper of energy has found stillness? Does time simply stop, or does it too transform? To imagine this final moment, you must picture not darkness, but equilibrium, an endless, gentle grey where nothing is hotter or colder, closer or farther, younger or older. Every atom, every photon, every grain of energy has settled into balance. The universe no longer changes, and so time has nothing to measure. The clock, if there still is one, no longer ticks. The story has reached a page with no words left to turn. For many physicists, this state is known as heat death, but that phrase sounds colder than the reality it describes. It's not destruction, it's rest. The universe has run its course, and now lies still, like snow that has stopped falling. All the fires are out, all the winds have settled. It's the most peaceful moment imaginable, if moment can still be said to exist. And yet, even this stillness holds questions. What happens when the story reaches a pause so complete that nothing moves? Is that the true end, or could it be the space between breaths? the quiet before another beginning. The poet in you might imagine the universe taking a long inhale, then exhaling across billions of years. What we call the Big Bang could have been one such breath, the sudden exhale of energy into being. If so, then perhaps the final silence we've just imagined is not an ending, but the long, patient inhale that prepares for another expansion. Some cosmologists have proposed that this could happen, that the universe, after expanding to its greatest reach, may one day reverse its motion. Gravity, though faint in the face of dark energy's push, could eventually pull everything back inward. Galaxies would slow their drift. The cosmic fabric would tighten. The stars would grow closer again. And then, in a future beyond imagining, everything might collapse back into a single brilliant point, a big crunch. It would be the mirror image of the beginning, the cosmos folding back into itself, light returning to the source. If you try to imagine such a thing, do not picture fire and chaos. Think instead of a great heartbeat, a contraction after a long expansion, a pulse that has no end because it will rise again. Some believe that this cycle could continue endlessly. Big bangs followed by big crunches, the universe expanding and collapsing, breathing forever. In this vision, time doesn't die. It loops. Every ending is only a new beginning, written in a different language. Others imagine a softer renewal, the big bounce. In this idea, the collapse of one universe might give birth to another, not through destruction, but through transformation. The immense compression of matter could ignite a new expansion, a new space, a new timeline. The cosmos, instead of being a one-way journey from order to stillness, could be a wheel, turning, pausing, and turning again. And there are still other possibilities. Perhaps the universe will never reverse at all. Perhaps dark energy, that strange force accelerating the expansion, will continue to stretch space faster and faster. If it keeps growing stronger, the fabric of the universe could be torn apart. Galaxies would drift away until their light could never reach each other. Then the stars themselves would be pulled from their orbits, atoms from their bonds, even the smallest particles from their own structure. This is sometimes called the Big Rip, though the name sounds far more violent than the reality might be. In truth, it would be a quiet unmaking, the universe expanding itself into transparency, every form dissolving back into pure distance. If the Big Rip is the universe's way of releasing itself, then the Big Crunch and Big Bounce are its way of returning, breathing in again. Both are different ways of describing one simple, universal rhythm: expansion and collapse, tension and release, awakening and rest. The universe may be vast, but it moves with the same grace as a wave, or a lung, or a human heart. And then there are those who wonder whether the whole question of beginning and ending might not be an illusion at all. Some physicists, like Julian Barber, have suggested that time itself is not a river flowing from past to future, but an illusion born from the way we remember change. In this view, each moment in the universe exists all at once, not as steps along a path, but as points on a vast landscape. What we call time is simply the way our minds travel across that landscape, like a bird flying through still air. The past and the future are both here. We are only ever visiting one part at a time. If that is true, then even when the last star fades and the last atom dissolves, the earlier moments, the ones filled with light and warmth, will still exist, eternally preserved in the structure of reality. The universe would not die. It would simply forget how to move. The memory of every sunrise, every heartbeat, every spark of thought would remain, frozen in the tapestry of all that ever was. In that sense, death becomes an illusion too. What fades for us may still live elsewhere in time. What ends in one place may begin in another. The stillness at the end of the universe may already hold the next beginning, curled quietly inside it, like a seed waiting for the thaw. There is something deeply human about this cosmic reflection. We too live within cycles, waking and sleeping, breathing in and out, beginning and ending countless times throughout our lives. Each moment of stillness we experience, each pause between breaths, is a tiny echo of that cosmic rhythm. The universe moves within us just as we move within it. So if the story truly ends in stillness, let it not feel like loss. Let it feel like a return. The same elements that built the first stars built you. The same light that shone at the dawn of time still crosses your skin when you stand in sunlight. You're a chapter written in the same ink as the cosmos itself. Temporary, but also eternal, because you are part of a pattern that never stops renewing. And perhaps, after the last whisper of energy has drifted through space, there will be another spark, a fluctuation, a tiny disturbance in the silence. Not an explosion, but a blooming. From it, new light might rise, new stars might gather, and a new story might unfold. In that story, everything we could live again, rearranged into new forms, remembering faintly what it felt like to shine. From here, the path begins to turn toward the horizon beyond endings, toward the possibility that what lies beyond our universe may not be nothing at all, but something waiting to be born from emptiness itself. As the light of the last stars fades behind us, we drift into a quieter realm of the cosmos, a place where space begins to reveal its true texture. At first, you might imagine the universe as a dark, endless void scattered with a few lonely galaxies. But if you could step back far enough, farther than any telescope has ever seen, a hidden pattern would begin to appear. The galaxies are not scattered at random. They form threads, long and luminous, weaving a structure so delicate it could be mistaken for lace. Between these glowing filaments lie enormous spaces of almost perfect emptiness, the silent rooms of creation. Astronomers call this grand pattern the cosmic web, but you don't need to remember the name. It's easier to think of it as a sponge made of light, where each glowing wall is built from galaxies, and each hollow bubble is a vast region of near-nothingness. In the glowing threads, matter gathers, stars ignite, and planets spin. In the hollows, space stretches thin and quiet, holding its breath. This vision isn't poetic imagination alone, it's something we've mapped with care. In the early 2000s, scientists used enormous sky surveys, including one called the Sloan Digital Sky Survey, to measure the positions of millions of galaxies. When they connected those points, the result looked almost alive. Clusters, filaments, and gaps, all repeating on scales too immense for language to hold. The bright regions formed a cosmic skeleton, and the dark gaps became the spaces in between. It was the first time humanity had seen the universe not as a random scatter, but as an intricate design. If you could hold that model in your hands, the largest known structures would make you pause. Some filaments stretch for hundreds of millions of light years. Each one is a chain of galaxies connected by invisible strands of gravity, drawn together by the pull of dark matter, that unseen material that makes up most of the universe's mass. Between these chains, the voids open up, some so large that they could swallow entire clusters of galaxies and still have room to spare. The numbers that describe these distances are far beyond our everyday sense of scale. But you don't need to count them, you only need to feel their rhythm. Imagine a landscape where every point of light is a galaxy, and the darkness between them stretches farther than your mind can follow. Imagine the silence of that space. Not a silence you can hear, but one you can feel, like the stillness of snow before dawn. It's tempting to think of these voids as empty, but they are not truly nothing. They contain thin traces of gas, faint whispers of dark matter, and the soft pull of gravity that connects them to everything else. Even emptiness, it seems, has structure. The universe is a web of balance, every bright cluster mirrored by a hollow, every presence paired with an absence. In this way, nothingness is not a failure of creation, it's part of its design. If you look closely at the edges of those voids, you can see how galaxies gather there like frost along the rim of a window. Matter prefers company. It clings and clusters. Over billions of years, gravity has drawn it into filaments, leaving the interiors of the voids thinner and thinner. The result is a universe that looks almost cellular, bright boundaries surrounding vast transparent interiors. It's as if the cosmos learned to grow like an organism, shaping itself into tissues of light and shadow. Scientists have tried to describe this pattern mathematically, using models that track how tiny fluctuations in the early universe grew into the web we see today. In the first moments after the Big Bang, small variations in density, slightly heavier here, slightly lighter there, acted as seeds. Gravity pulled the heavier regions together, forming galaxies and clusters, while the lighter regions expanded faster, becoming the voids. Over time, this difference stretched and deepened until the cosmic web emerged. You don't need to imagine equations to understand it. You only need to picture the way foam forms on the surface of water, bubbles touching, merging, separating, each shape defined as much by what isn't there as by what is. If we could travel across one of these voids, it would be like sailing through an invisible sea. A few dim galaxies would drift in the distance, each one separated from its neighbours by unimaginable space. The background glow of the universe would be faint, the temperature just a few degrees above absolute zero. Even the faint radiation left over from the Big Bang would feel stretched and weary there, its once warm waves now long and cold. Yet the emptiness would not feel dead. It would feel calm, vast and strangely alive, a presence made of absence. There's a quiet irony here. For all its enormity, the universe is mostly made of nothing. The atoms that make up all stars, planets, and living things are confined to the tiniest slivers of existence. If the cosmos were compressed into a single volume, the matter we know would occupy less than 1 part in a billion of it. Everything else would be space, open, silent, and invisible. And yet, that emptiness is not useless. It allows motion. It gives room for galaxies to breathe, for light to travel, for thought itself to unfold. In a sense, we owe our existence to these voids. Without them, gravity would have nowhere to pull from and nowhere to build contrast. The stars need darkness in order to shine. The universe, like a painting, draws its meaning not only from colour, but from the spaces between brushstrokes. Sometimes, when cosmologists talk about this structure, they describe the universe as flat on large scales, meaning that space, though curved by gravity around stars and galaxies, averages out to something remarkably smooth. But smooth doesn't mean simple. The web of galaxies, the filaments of light and the voids between them form a harmony of opposites. Expansion balanced by attraction, density balanced by emptiness. It's a rhythm the universe has followed since its earliest moments, and we're part of it, living on a tiny speck near one glowing thread. If you close your eyes and imagine it, you might picture the cosmic web as a vast tapestry stretched across infinity. You're somewhere within that weave, not at the centre, not at the edge, but in one of the countless intersections where light and shadow meet. The atoms in your body are the same ones that drifted along those filaments billions of years ago, pulled together by gravity, condensed into a star, and eventually released again. You're not separate from the web. You're one of its threads, a brief bright knot in the long fabric of space and time. The more we study these structures, the more they seem to pulse with quiet order. Even the largest voids, once thought to be barren, may hold faint galaxies hidden from our view. Small beacons in vast halls of nothing. Space, it seems, refuses to be truly empty. It is always whispering, always moving, always alive with potential. And as we drift further into this story, we begin to wonder, What are these voids really made of? Are they simply leftovers of cosmic growth, or could they hold secrets deeper than we know? Perhaps emptiness itself is not absence, but a kind of presence, a medium through which the universe continues to breathe. Our quiet exploration now turns toward those deeper hollows, the giants of emptiness, to see what mysteries might lie inside their walls of silence. As we drift further into the story, the filaments of galaxies thin behind us until even their faintest glow dissolves into silence. We are entering the hollows, the vast echoing chambers that lie between everything. These are the cosmic voids, the true oceans of the universe, so large that the mind can barely hold them. They're not simply gaps between galaxies. They're entire realms of space where almost nothing has ever happened, where even light seems reluctant to wander. Imagine floating in a region so immense that, even travelling at the speed of light, it would take hundreds of millions of years to cross. The nearest galaxies would appear as pale, distant smudges, and the darkness between them would be nearly pure. Space itself would feel stretched, thin, soft and empty, like fabric pulled to its limits. Here, the silence is not the absence of sound, but the presence of peace. Nothing moves quickly, nothing collides. The universe is resting between its own heartbeats. Among these silent expanses are the giants, the Bhuta's void, the Eridanus supervoid, and the Cain's Venatici supervoid, each one a cathedral of emptiness large enough to hold tens of thousands of galaxies, though only a handful drift inside. The Bhuta's void alone spans more than 300 million light-years across, a gulf where 10,000 galaxies should have been, yet only 60 wander, lonely as lanterns on a dark sea. When astronomers first mapped it, they called it the Great Nothing, as if even language bowed before its scale. But these voids are not blank. They are full of stories written in absence. Light itself changes as it crosses them. When photons, the tiny carriers of illumination, travel through such vast, underdense regions, they lose a little energy. The journey stretches them, cools them, makes them slightly less bright when they emerge. It's as if light tires while walking through loneliness. Scientists call this soft fading the Sachs-Wolf effect, but you can think of it as the way light sighs when the road is too long. One of the most curious examples lies in the direction of the Eridanus supervoid, where the cosmic microwave background, that ancient afterglow of the Big Bang, shows an unusually cold patch. It's as though the earliest light of the universe dimmed itself as it passed through a vast gulf of nothingness. Some have wondered whether this cold spot hints at something deeper, a window into another region of the cosmos, or even another universe brushing against our own. Others think it's simply the natural texture of the cosmic web, the result of chance and gravity playing out over unimaginable distances. Either way, it stands as a reminder that even emptiness leaves fingerprints. The idea that such enormous regions exist, places hundreds of millions of light-years wide yet nearly empty, changes how we see the universe. We often imagine space as being mostly filled with stars, but in truth, the opposite is closer to reality. The majority of the cosmos is made not of galaxies, but of the voids between them. These spaces are the scaffolding upon which everything else is built. They give shape to existence by defining where it is not. If you could observe the universe from a great distance, you'd see that these voids aren't truly round or uniform. They merge and stretch, overlapping like bubbles in foam. Their boundaries shift over time, expanding slowly as matter drifts toward the surrounding filaments. The edges of the voids glow faintly with galaxies, the luminous residue of what was drawn away. It's almost as if the universe breathes, inhaling into brightness, exhaling into emptiness. To describe their scale in human terms is nearly impossible, but let's try. If the Earth were shrunk to the size of a single grain of sand, the Bhuta's void would still be larger than the entire observable universe on that scale. It's not just big, it's beyond the reach of intuition, and yet, when we map it, we find that it has structure. thin threads crossing its interior, tiny islands of galaxies resisting isolation. Even in the heart of emptiness, gravity leaves patterns, faint as veins in marble. The discovery of these voids came as a surprise. When astronomers first measured the distances to galaxies in the late 20th century, they expected to find them evenly distributed. Instead, they found walls and gaps, like the surface of bubbles stacked together. The universe was not random. It was architectural. The filaments and voids together formed something akin to a cosmic honeycomb, not static but slowly shifting as expansion continues. The Sloan Digital Sky Survey and other observatories have revealed hundreds of such voids, each with its own size, shape, and quiet personality. Some are relatively small, a few tens of millions of light-years across, while others sprawl across a significant fraction of the visible universe. Inside these voids, time feels stretched. A photon, once released from a distant galaxy, might wander through the emptiness for billions of years without meeting another atom. If you could somehow follow that photon, watching it drift, you would see it red shift, its colour sliding slowly toward longer wavelengths as space expands. By the time it leaves the void, it carries the fatigue of its long journey, a reminder that even light grows older as it travels. It's a haunting thought. That light itself can grow weary. But perhaps it's also comforting. It means the universe keeps records of its journeys. Each beam of light carries a story of where it has been, through clouds, across clusters, into voids, out again, until at last it reaches a telescope or an eye, completing a journey that began before there were even planets to see it. There's another mystery hidden in these vast hollows. Some physicists have speculated that voids could be shaped by more than just gravity. They may also reflect the influence of dark energy, that mysterious force driving the universe's expansion. If dark energy pushes outward more strongly in emptier regions, then voids might grow faster than the filaments that surround them, like bubbles rising in a boiling pot. In that sense, the universe could be thought of as a cosmic brew, some regions thick with matter, others thinning into transparency. And yet, emptiness is never absolute. Even the largest voids are filled with faint fields, particles, and possibilities. Space itself hums with the energy of the vacuum, the restless fluctuations that give rise to the smallest sparks of creation. So while the voids may appear lifeless, they are in a deeper sense alive, not with form, but with potential. As we drift through this great emptiness, imagine what it would be like to stand at its centre. There would be no up or down, no horizon, no sense of distance. Only a faint, omnipresent glow from every direction, stretched by time and distance into a pale whisper of light. You would feel as though you were floating inside the universe's own thought, surrounded by calm so vast it could almost be mistaken for eternity. But what carved these hollows in the first place? How did such vast spaces of near nothing come to exist in a universe born so full of energy and light? To answer that, we must go back, not in distance, but in memory, to the earliest instance after the universe began, when all the patterns we see today were still ripples in a sea of possibility. If we follow the thread a little further back in time, the quiet hollows of the universe begin to whisper their origin stories. The great voids that now drift between galaxies were not always there. In the beginning, there were no filaments of light, no clusters, no structure at all, only a trembling sea of energy, smooth and bright, like mist before sunrise. From that mist, the first imperfections began to form. They were small, faint ripples, changes in density no larger than 1 part in 100,000. But over time, they became the fingerprints of everything that would exist. Galaxies, stars, planets, and the vast empty rooms between them. It is easy to think of emptiness as an afterthought, the space left behind once matter gathered elsewhere. But in truth, The voids were shaped at the same moment the galaxies were born. They are twins, light and dark woven together from the same cosmic fabric. To understand how they came to be, we must go back to the universe's first instant, when space itself began to unfold. In that unimaginably early era, everything we know was compressed into something smaller than a grain of dust, and yet full of potential. Then, in an event physicists call inflation, space expanded with astonishing speed, faster than light, though not breaking any rule, because it was not matter moving through space, but space itself stretching outward. If the Big Bang was the sound of a drum being struck, inflation was the vibration that followed, expanding the drum's skin in all directions. Those tiny quantum ripples in density, the smallest wrinkles in the smoothness, were stretched as well, growing from subatomic whispers into the first outlines of the cosmic map. Over time, the slightly denser regions became the filaments and clusters where galaxies would form. The slightly thinner ones became the voids. You can think of it as dough rising in an oven. As some spots swell with bubbles of air, others remain thinner, leaving pockets of lightness in between. When the baking was done, when the first stars began to shine, those pockets were already in place, destined to become the cosmic voids we see today. Some scientists believe that dark energy, the mysterious pressure that drives the universe's ongoing expansion, continues to shape the voids even now. Because it pushes most strongly where matter is scarce, the emptier regions may stretch faster than their surroundings. Over billions of years, that means the voids grow larger, while the filaments of galaxies become thinner and more delicate. The universe, in a sense, is still exhaling, and the voids are where that breath flows most freely. But not all emptiness is made the same way. Other theories imagine different origins, variations in the fabric of reality itself. One idea suggests that, in the universe's earlier seconds, the fabric of space might have contained folds or creases, known poetically as topological defects, places where expansion tugged unevenly, leaving wrinkles in the cosmic texture. Those wrinkles could have stretched into the great gaps we see today. You might picture it like a sheet of silk pulled too quickly. A few small gathers become permanent, frozen into the weave. Another possibility is that some of these voids were carved by invisible rivers of dark matter collapsing elsewhere. As dark matter pulled ordinary matter into dense filaments, it left behind enormous underdense regions, like the negative spaces in a sculpture. Gravity, though it pulls things together, can also create emptiness by moving matter away. In this way, the universe shapes itself both by attraction and by release. A few researchers have even wondered if clusters of ancient black holes could have played a part, their intense gravity pulling matter into tight knots, leaving behind regions of absence around them. In that scenario, the voids might be the shadows of primordial giants, unseen but still felt. It is a haunting thought that the shape of nothingness could be sculpted by the weight of everything. And then there are the more speculative ideas, that the voids might be the thinning walls between universes where the bubble of our cosmos brushes against others. In this vision, reality is not one continuous expanse but a vast sea of bubbles, each containing its own laws, its own light, its own time. When two bubbles drift close, the space between them could stretch thin, forming a great void where the pressure of existence balances perfectly. We may never know if this is true, but it's an image that lingers. The thought of our universe floating on an invisible ocean, one bubble among countless others, each trembling with its own version of reality. All of these theories share one quiet truth. Emptiness is not an accident. It is a feature of creation itself. Without the hollows, there could be no structure, no contrast, no balance. The universe needs silence as much as it needs sound. The voids give shape to the web of galaxies, defining where the light can gather. They are the pauses between notes that make the cosmic symphony legible. If you imagine yourself standing at the edge of one of these voids, looking out over its immeasurable breadth, you might notice something subtle. The emptiness does not feel oppressive. It feels spacious, calm, alive with potential. It is the same feeling you get when you stand before a blank canvas or a quiet horizon. The awareness that something could happen here, that creation might begin again. Even the faint matter that lingers in the voids may one day give rise to new wonders. The particles drifting there are so rare that they might never meet another for millions of years. But time, as we've seen, is patient. Gravity might eventually coax them together, forming small clouds, faint stars, or something we have yet to imagine. Emptiness, it turns out, is not sterile. It is fertile in a different way. Not by producing things now, but by preserving the possibility of them. In a more human sense, these cosmic voids reflect a kind of truth we know instinctively. Every silence we experience, in thought, in art, in love, in grief, carries within it the seed of something new. Stillness is never wasted. It's the ground from which renewal grows. The universe follows that same quiet wisdom. It builds by leaving space. Perhaps that is why, when we look out into the black between galaxies, we feel both awe and comfort. The voids remind us that absence is not failure, it's invitation. It's the part of the universe that listens. As we drift onward, the idea of nothingness begins to shift. These hollows, once seen as gaps, now feel more like gateways, thresholds between one kind of existence and another. What lies beyond them may not be empty at all, but something waiting, something unseen, something that hums beneath the silence like the prelude to a song. The trail of our story now carries us toward those possibilities, to the speculation that these silent rooms of space might be portals, connecting not only galaxies but realities. The trail of clues leads us gently deeper into speculation, into the idea that the vast silent hollows of space may not be endings at all but openings. It is one of the most mysterious thoughts in modern cosmology, that the emptiest parts of our universe might also be its most connected. What if, rather than being the blank spaces between galaxies, these voids are thresholds, soft places in the fabric of reality where the rules we know begin to thin? When we picture the universe, we often imagine it as a great island of galaxies surrounded by nothing. But what if our island is only one among many, floating on an invisible ocean? Some cosmologists describe it this way: a sea of universes, each one like a shimmering bubble on a limitless surface. Inside each bubble, the laws of nature may differ. In one, gravity might be stronger. In another, atoms might never form. Ours happens to be one where stars can shine, where chemistry can dream, where consciousness can ask why. Now imagine those bubbles brushing against each other. Where they touch, the surface between them might stretch thin, like a soap film catching the light. In those thin places, the physics of one universe could echo faintly into another. The great voids we see, those enormous hollows where galaxies are scarce, could be the shadows of such contacts. They might be the quiet signatures of other universes pressing softly against our own. This idea belongs to a family of theories known collectively as eternal inflation, though, rather than treat it as an equation, you can think of it as a field of endless blossoms. The early universe, in this view, never stopped expanding. While our bubble of space cooled and slowed into stars and matter, the space beyond it continued to grow, budding off new regions that inflated into their own realities. The cosmos in this telling is not one grand explosion, but a perpetual garden, each universe a flower blooming from the stem of eternity. Inside our particular bloom, the edges of space may still carry traces of the others, subtle gravitational fingerprints, gentle distortions in the cosmic microwave background, hints that we live in a neighbourhood rather than a solitary island. The evidence is uncertain, faint, and perhaps forever beyond proof. But the image lingers because it feels strangely natural. Creation, after all, has never favoured simplicity. Why should there be one universe when there could be many? If the voids truly are portals, or at least windows into other regions, they would not be tunnels in the way science fiction imagines them. There would be no doorway to step through, no shimmering ring of light. They would be regions of thinner law, places where the constants of nature lose their rigidity and possibility briefly opens wider. Perhaps, at their deepest points, the strength of gravity shifts slightly, or the rhythm of time trembles. It would be imperceptible to any traveller, right? Too vast, too subtle, but it might leave marks on the light that passes through. In that sense, the voids would be not entrances, but echoes, signs that the universe is larger than its visible self. The dark between galaxies could be the space where other universes lean close enough to whisper, and we, listening across billions of years, hear only the faintest murmur in the form of a cold patch or a dimming of the ancient glow. There's something deeply poetic about this thought, that the universe might be porous, that its boundaries are not walls but membranes. If space is a fabric, perhaps the voids are its thin spots, where the weave stretches to transparency. When you look into them, you're not staring into nothingness, but into a deeper layer of reality itself. And yet, even if no other universe ever touches ours, the idea still carries meaning. The voids, in their immensity, remind us that existence is never uniform. It ripples, breathes, expands, and folds. The presence of emptiness next to fullness, silence next to sound, is what allows the cosmos to express its shape. In music, it's the rests that give the melody its rhythm. In art, it's the blank space that lets the image breathe. The same is true of reality. It might even be that the universe's tendency to create voids is connected to the same principle that allows complexity, the balance between chaos and order. Too much structure and nothing can change. Too little and nothing can form. The voids create contrast, allowing galaxies to stand out, light to travel, and energy to find direction. Without them, the cosmos would be a featureless blur, bright, yes, but meaningless. In a quiet way, this brings us back to ourselves. Human beings too are shaped by what we leave open. Between our thoughts there are pauses, between our words there are silences. Those gaps are not mistakes. They are the spaces where understanding breathes. The universe, on its grander scale, does the same. It speaks in galaxies and rests in voids. Some thinkers have gone further, wondering if consciousness itself might be a kind of bridge between universes, a reflection of how reality folds inward to observe itself. The voids, they suggest, could be physical metaphors for something mental, the still spaces between experiences, where perception finds meaning. It's a speculation beyond measurement, but not beyond wonder. If you were to stand in the centre of one of those giant voids, if such standing were possible, you would find yourself surrounded by faint distant lights, each one a galaxy shining from the edges of the abyss. There would be no sound, no wind, no warmth, only the hum of your own thoughts. Yet perhaps, in that profound silence, you would feel something that resembles peace. You would be inside the universe's own meditation, where everything it has created pauses for a moment to listen to itself. And maybe that's what the voids are. Not portals in the mechanical sense, but portals in the emotional one. They are the universe's way of remembering stillness, of balancing creation with quiet. They remind us that not every question demands an answer, not every space needs to be filled. As our journey continues, the path begins to curve inward again. The more we learn about the great emptiness between galaxies, the more it mirrors the silence before the beginning. What if the space that surrounds us now, vast, calm, expanding, carries the same potential that once gave birth to everything? What if these voids are not remnants, but rehearsals, practicing the silence from which the next universe might one day rise? To understand that possibility, we'll need to turn our gaze not outward, but backward, to the moment before light itself existed, before time began to count. Because somewhere beyond even these great hollows, in the quiet before creation, the first breath of the cosmos was waiting to be drawn. Our quiet exploration now turns inward. After so many journeys through distance and time, through stars and emptiness, the mind begins to recognize a rhythm, a deep pulse that has been there all along. The farther we travel into the universe, the more it begins to resemble something familiar, the silence within ourselves. It's as if the cosmos, after unfolding into galaxies and light, gently folds back, whispering, "Be still and listen." If you've ever sat in a room after the noise has faded, after the hum of machines, the chatter of voices, the rustle of wind, there's a strange fullness to what remains. It isn't pure silence. It has texture, a faint vibration that feels alive. Physicists might say that even in a vacuum, space is never truly empty. Tiny fluctuations dance in and out of existence, appearing and vanishing faster than any clock could measure. But you don't need to think in terms of particles to feel it. The silence of space and the silence of the mind both have a heartbeat. When astronomers map the cosmic voids, they see that even the emptiest regions hum faintly with radiation, with gravitational waves rippling from faraway mergers, with a soft glow of particles so sparse they may never collide. It is a whisper of being that refuses to fade. In the same way, when you quiet your thoughts, there is still something that moves inside, a faint awareness, like the background glow of the soul. Perhaps the void between galaxies and the stillness between thoughts are not so different. Both are spaces where potential lives, waiting to become something again. It's tempting to see silence as absence, but perhaps it's better to think of it as invitation. Between the words of a sentence, meaning finds its shape. Between notes in a song, music finds its beauty. Between stars and galaxies, the universe finds its structure. The voids, both cosmic and human, are what make the light visible. They are the stage upon which everything else can exist. When we first began exploring space, we thought we were moving away from ourselves, away from the Earth, away from home. But the deeper our telescopes gaze, the more they reveal patterns that mirror what we already carry inside. The spirals of galaxies resemble the swirls of fingerprints, the networks of neurons, the flow of rivers and veins. The voids between them echo the pauses between heartbeats, the spaces between thoughts. It's as if the universe repeats one great design, fractal and infinite, scaled up and down across every level of being. If you think of the cosmic web as the universe's mind, then the voids might be its moments of reflection. They are not failures of creation, but its breathing spaces, the pauses that keep the whole from becoming noise. Without them, everything would overlap, chaos swallowing pattern, sound devouring harmony. Emptiness is the cosmos remembering balance. Sometimes, when astronomers look at the data from those vast hollows, from regions like the Boötes void or the Eridanus supervoid, what they find most striking is not the absence of matter, but the persistence of faint light that still travels through them. Even the loneliest photon, the smallest quiver of energy, continues its journey. It never gives up crossing the dark. That's the universe's quiet determination, the echo of creation that refuses to stop moving forward. Maybe that's why these immense silences feel strangely comforting. They remind us that stillness is not the same as nothingness. Stillness can hold everything, all memory, all possibility, suspended like dust motes in sunlight. The emptiness between galaxies is not void of meaning. It's where meaning gathers itself to begin again. You can test this truth in your own small universe. Sit quietly. Notice your breath. Between the inhale and exhale, there's a moment, a pause so small it barely exists, and yet it's where everything resets. That pause is your personal void, the still point that lets the next breath happen. Without it, there would be no rhythm, no flow, no life. The cosmos, in its vastness, works the same way. Every burst of creation needs its silence. Every act of becoming needs its rest. Philosophers have long wondered whether the universe is conscious, whether awareness might be woven into the fabric of existence itself. If so, then perhaps the voids are its meditative moments, where awareness turns inward and simply is. After all, even consciousness depends on contrast. Thoughts arise only against the backdrop of stillness. The universe might not think as we do, but it knows how to pause, and that pause is where wonder lives. When you look at the night sky, you're not only seeing light that has travelled across billions of years, you're also seeing the darkness that made that journey possible. Without the dark, there could be no stars. Without the void, there could be no galaxies. Without silence, there could be no voice. And without the stillness between moments, there could be no time at all. In the end, the cosmic voids are less about what's missing and more about what they allow. They let light breathe. They give motion space. They give time a place to stretch. They are not errors in creation, but its foundation, the unseen scaffolding that holds everything together. Perhaps that is what the universe has been teaching us all along, that what we call nothing is the quiet strength beneath everything, that the spaces between are as sacred as the things themselves, that in the stillness between heartbeats, in the pauses between galaxies, in the silence between beginnings and endings, something eternal listens, and so we listen back. We listen to the silence of space and find that it isn't silent at all. It's full of soft motion, slow breath, unhurried patience. We listen to our own quiet and realize that it too hums with life. The cosmos outside and the cosmos within share the same stillness, the same depth, the same endless possibility. As we rest here, in the calm between stars and thoughts, the universe feels closer than ever, not a distant expanse, but something alive that moves through us as much as we move through it. In this silence, you can almost hear it breathing, vast and slow, as it waits for whatever comes next. And from that deep and endless quiet, the story now turns one final time, toward the beginning before beginnings, the dawn before light, when even silence had not yet been born. From the vast quiet of the cosmic void, the path now leads us backward, past galaxies, past starlight, past even the faint afterglow that fills the universe. The deeper we travel into that silence, the more the familiar world begins to fall away. Space loses its shape, time loosens its hold. What we're left with is something beyond imagination, the hush before creation, the breath before the first dawn. If the universe had a beginning, what came before the first second? What was there to count before time began to count itself? The question seems simple, but it holds the weight of all existence. Some might say there was nothing, but in physics, even nothing is never truly empty. It has energy, potential, a quiet tension like the surface of still water just before a ripple forms. In that silent potential, something stirred. You could call it a quantum fluctuation, but the name doesn't capture its softness. Think of it instead as a whisper in absolute stillness, a gentle imbalance that broke the perfect symmetry of nothingness. One tiny pulse of energy appeared where before there was only calm. It didn't burst or roar, it trembled, and in that trembling everything began. To picture this moment, imagine dew forming from invisible air. There's no sound when it happens, no warning. The air simply cools, the invisible becomes visible, and the first droplet gathers on the tip of a leaf. The birth of the universe may have been something like that. a natural consequence of stillness reaching its limit and deciding without decision to become. Physicists often say that the universe came from a quantum fluctuation in a vacuum, but those words make it sound mechanical, as if reality had a switch. It's gentler to think that the universe didn't explode into being, but unfolded, like a petal opening in the dark, revealing the possibility of light. The moment we call the Big Bang might have been less an explosion and more a release, a sigh that transformed stillness into motion. Before that moment, there was no before in any ordinary sense. Time itself was part of what was created. Asking what happened before the universe began is like asking what's north of the North Pole. Direction loses its meaning, but curiosity keeps asking anyway, because the human heart wants to find beginnings even where beginnings don't exist. The first instant of existence, the first measurable shimmer, was unimaginably brief. In a fraction of a heartbeat, space expanded at a speed that defies comparison. One moment, everything was smaller than a particle. The next, it had grown enough to hold galaxies that didn't yet exist. We call that event cosmic inflation, but perhaps it's better to think of it as the first breath, the universe inhaling and exhaling itself into being. During that expansion, energy condensed into matter, and matter began to cool and separate. The smallest differences in density, slight ripples in the new fabric of space, became the seeds of every star and planet that would ever form. The pattern of the universe was already woven into that first flutter, like the design of a leaf encoded in the seed. Even now, billions of years later, the faint background radiation that fills space still carries that ancient pattern, the echo of the first vibration. What caused that first whisper? We don't know. Maybe the laws of physics simply allow creation to happen naturally, the way rain gathers in clouds when the air becomes heavy enough. Maybe nothingness, left alone for long enough, cannot help but give birth to something. Or maybe this was not the first time it happened. Maybe universes have been rising and fading forever, like waves on an endless shore. When you think about it, nothing has always been a difficult idea to hold. Even in our daily lives, emptiness is rarely empty. A quiet room still has air. A pause in a song still has resonance. Perhaps the void before time was like that, a potential so pure it could no longer remain potential. It had to unfold, to express, to become. And when it did so everywhere at once. The Big Bang didn't happen at a single point. It happened everywhere simultaneously. Every location in the universe was once that same origin. That means that right here, where you sit now, was once part of that first bright breath. The same point of creation that existed 14 billion years ago is not somewhere far away. It is everywhere, including here. There's a quiet comfort in that realization. You're not in the universe. You're part of the universe. The atoms in your body are direct descendants of that first trembling of energy. The warmth in your hands is a continuation of the first warmth that ever existed. The light you see is made of the same pulse that broke the silence of nothingness. Perhaps then the beginning was not something that happened once long ago. Perhaps it is something that happens continuously. The universe renewing itself moment by moment, recreating the miracle of existence again and again in every vibration of every particle. The Big Bang, then, is not just a past event, but a perpetual motion of being. You can sense that continuity even now. Every breath you take mirrors the expansion and contraction of the cosmos. Each heartbeat is a reminder that creation is rhythmic. It pulses, it rests, it pulses again. The universe has been doing the same for billions of years, breathing, expanding, cooling, and perhaps, in the far future, preparing to inhale once more. If you could stand outside of time, if such standing were possible, you might see the whole of creation, not as a sequence, but as a single shimmering tapestry. The first second and this very moment would exist side by side, threads in the same pattern, The birth of light and your awareness of it would be two aspects of the same unfolding. In that view, there is no true beginning or end, only the gentle turning of eternity upon itself. And so, in the quiet before the first dawn, we find that the universe was never truly alone. It carried within its stillness the possibility of everything, the stars, the voids, the questions, and even you. That first whisper was not the start of a story. It was the story remembering itself. But if that whisper became our universe, perhaps there were others before it, breaths drawn and released in endless succession. In the next step of our journey, we'll listen for those older rhythms, the universes that breathe, rest, and begin again. If we follow that first whisper a little further, we begin to sense a rhythm within it, a pulse, soft but steady, echoing through everything. The universe, vast as it is, does not feel like a single explosion frozen in time. It feels alive. It expands, it cools, it drifts towards stillness, and some scientists wonder if one day it might inhale again. The idea is both ancient and new, that the cosmos itself might breathe. In the earliest philosophies, long before telescopes or equations, people imagined creation as a cycle, the world born, fading, and born again. The Hindu concept of kalpa spoke of universes expanding and dissolving endlessly, like waves rising and falling on the ocean of eternity. The Greeks too spoke of ages that repeat, a cosmic fire rekindle after its own ashes cool. Modern physics, though wrapped in different language, has found its way back to a similar thought. Perhaps, these scientists say, our universe is not the first. Perhaps there were others before it, universes that expanded, lived their long lives, and then folded back in on themselves, collapsing into dense seeds that sparked again. It's a model sometimes called the Big Bounce, and you can think of it as the heartbeat of reality, expansion as exhale, contraction as inhale, eternity in between. In this vision, the universe does not end in silence but in renewal. When the cosmos grows too old, gravity may overcome its outward rush. Galaxies that have drifted apart for trillions of years could begin to fall inward again. The great tapestry of space might fold back toward its centre, every thread drawn home. But instead of collapsing into an unthinkable point, the fabric could rebound, compressed just enough to ignite another expansion. Out of the ashes of one universe, another begins. Some modern theories, built from what's called loop quantum gravity, imagine space itself as a kind of woven cloth made not of threads, but of tiny loops, unimaginably small rings of geometry. At scales beyond any microscope, space might not be smooth at all, but grainy, textured, resilient. When pushed to extremes, this web doesn't tear or break. It bends and then springs back. In that way, the collapse of one cosmos could become the recoil that launches another. No singularity, no infinite density, only transformation. It's easy to get lost in the mechanics, but the essence is simple. The universe breathes. It stretches outward, then inward, not once but forever. Every cycle wipes the slate clean while carrying forward traces of what came before, like faint fingerprints on a newly painted wall. Maybe every pattern we see, from the spiral of galaxies to the rhythm of our own hearts, is a quiet echo of that deeper pulse. If you imagine this process in slow motion, it becomes almost meditative. During expansion, galaxies drift apart, stars shine, life arises. During contraction, everything returns home, matter drawn inward, time compressing, temperature rising until the old world dissolves into light. Then, with a stillness that could last longer than a language can describe, the new breath begins. Expansion, rest, contraction, rest. A cosmic heartbeat that may have been beating forever. Some versions of this idea even suggest that the traces of previous universes might still linger in our own. The patterns of radiation we see in the night sky, the faint ripples left over from the early universe could carry echoes of older cycles. Like fossil imprints in stone, they may hint at lives lived before ours, not in human time, but in the deep time of creation itself. It's a comforting thought in its own way. If universes can be reborn, then perhaps nothing is ever truly lost. Even when the stars fade and galaxies dissolve, the essence of existence might endure, waiting for its next expression. In this sense, entropy, the slow march toward disorder, isn't an end, but a stage in the breathing of reality. What appears to fade might only be resting. To bring it closer to our scale, imagine a forest after winter. The leaves have fallen, the branches are bare, and the air feels empty. But within that stillness, life waits, not destroyed, only dormant. When the warmth returns, growth begins again, following rhythms so old they have no beginning. The universe might be doing something very similar, just on a scale so vast that we mistake its pauses for endings. It's also possible that each new cycle brings small changes, that the universe never repeats itself exactly. Just as no two breaths are identical, no two bounces may unfold the same way. Physical constants might shift slightly, shaping new patterns, new possibilities, perhaps even new forms of consciousness. In this way, the cosmos evolves, not only in space, but in experience. Some theorists have called this cosmic natural selection. In their view, every new universe carries the lessons of the last, subtly adjusted by the conditions that created it. A universe like ours, capable of complexity, of life, of thought, might be one that inherited a particularly fertile pattern from its predecessors. If so, then even the vast coldness between cycles is not waste, but a kind of gestation, eternity learning how to give birth more gracefully each time. Whether or not that's true, the metaphor of breathing remains powerful. It connects the infinite to the intimate. Each time you breathe in, you mirror the expansion of space. Each time you breathe out, you echo its contraction. The air moving through your lungs is older than the stars. Atoms born in ancient supernovae, recycled across billions of years, now participating in your quiet moment of life. The universe breathes through you, and you through it. In this way, the cosmic and the personal are the same motion at different scales. The universe expands into curiosity, contracts into reflection, then expands again. So do we, learning, resting, dreaming, beginning again. Perhaps the true rhythm of existence is not progress or decline, but balance, a steady alternation between everything and nothing, between light and shadow, between sound and silence. And maybe that balance explains why there is something rather than nothing at all. Because if existence were only stillness, it could never know itself. It needs movement to awaken, just as a lung needs air to feel alive. Creation, then, might not be a one-time event, but an ongoing gesture. A universe that inhales its own possibilities, exhales its own discoveries, and never truly stops breathing. As we drift through this thought, you might sense how the pattern continues. Each breath, each heartbeat, each cycle of sleep and waking, all reflections of the same underlying rhythm. The universe breathes, and in doing so it keeps time. From here, the trail of imagination widens again. If our universe breathes, perhaps it's not alone. Maybe it is one flower in a field that never stops blooming, each universe opening and fading in the infinite garden of reality. The path now carries us outward again, into an even wider vision, a dream of infinite variety. If the universe can breathe, if it can be born again and again, then a quiet question stirs like wind through tall grass. What if there isn't just one universe at all? What if our cosmos, with all its galaxies and laws and patterns, is only one flower in an endless field? This idea, called the multiverse, has become one of the most imaginative frontiers in modern cosmology. But it doesn't begin with wild speculation. It begins with the same curiosity that guided us from the atom to the stars. Scientists noticed that the conditions that allow our universe to exist are incredibly precise. The forces that bind atoms, the speed at which space expands, the balance between light and gravity, all of it had to align perfectly. A little more of one thing, a little less of another, and no stars could form. No life, no us. So the question arose, is our universe special, or simply one of many, each with its own rules? In some theories, it's not that the universe was finely tuned for life, but that many universes exist, each with different settings, and we simply happen to live in the one where life is possible. In other words, the cosmos may not be a single masterpiece. It might be a gallery. Imagine walking through an infinite orchard. Each tree bears fruit, but no two fruits are the same. Some are small and faint, others vast and heavy with stars. Each grows according to its own hidden rhythm, shaped by the soil of its particular laws. One fruit might be filled with light, another with shadow. Some may blossom for only a heartbeat, others for eternities. Ours, it seems, is a particularly fragrant one, balanced just right for curiosity to awaken and wonder to bloom. In this vision, creation is not a single event but a continuous flowering. Space itself acts like a field that never stops blooming bubbles, each one expanding into its own universe. This process, sometimes called eternal inflation, suggests that while our universe cooled and settled into stars, the larger cosmic field kept growing, producing new bubbles endlessly. Every bubble contains its own beginning, its own physics, its own unfolding of time. One of the early thinkers behind this idea, the physicist André Linde, once described it not as an explosion but as a garden. Each universe, he said, is like a separate blossom on the cosmic tree. It's an image that speaks as much to the heart as to the mind, a reminder that even science, at its most abstract, is still a kind of poetry. And if there are countless universes, their diversity would be beyond comprehension. In one, gravity might be stronger, pulling everything into dense, short-lived stars. In another, it might be weaker, letting galaxies spread out like smoke. Some might expand forever, never cooling enough for matter to form. Others might collapse too soon, blinking out like sparks. There could be universes of light, universes of shadow, universes where time flows in circles or not at all. To us, these are only imaginings. We cannot see beyond the boundaries of our own bubble, and light from other universes, if they exist, can never reach us. Yet, through mathematics and observation, hints arise. The faint patterns in the cosmic microwave background, the mysterious cold spots, the quantum fields that fill space, they all whisper that creation might be more abundant than we ever dared believe. And still, there's something humbling about it. If reality truly contains infinite universes, then we are both smaller and larger than we ever thought. Smaller, because our own cosmos becomes one among uncountable others. Larger, because the same principles that shape them shape us too. The same breath, the same spark, the same whisper in the stillness. Every universe, no matter how strange, is a variation of that first possibility, awakening into being. You might wonder what it would mean if there were versions of us in other universes, not identical, but reflections shaped by different histories. Perhaps in another cosmos you were born under a different star. Perhaps you never existed at all. Perhaps thought itself took another form, something we can't imagine. These are not questions with answers, but with echoes. The point is not to know, but to feel the vastness that such ideas reveal. In a way, the multiverse makes existence more intimate. If there are countless realities, then ours, this one right now, becomes all the more precious. It's the single blossom we can see, the one we inhabit. Just as a gardener tends one flower even while knowing the field is endless, we care for this universe because it's the one that has opened in front of us. And maybe, just maybe, the universes aren't separate after all. Some theories suggest that their boundaries might touch, that new universes could be born when two bubbles collide, the cosmic equivalent of ripples merging in a pond. If that's true, then the cold spots in our sky might be the faint bruises left by ancient collisions, the marks of other worlds brushing gently against our own. It's a haunting thought that somewhere beyond our cosmic horizon, another universe expands, never to meet ours, yet connected by the same origin. It's like hearing a distant song through walls of time, knowing it was written by the same composer, sung in a different key. Philosophers often ask, if everything possible happens somewhere, what does that mean for choice, for meaning, for purpose? But perhaps those questions miss the quiet beauty of the idea. The existence of many universes doesn't make ours less real. It makes reality itself deeper. Each cosmos, no matter how vast or brief, is a way for existence to express itself, another note in the endless chord of being. And if creation is that abundant, then perhaps even the end of our universe will not be an ending, but a continuation, one melody giving way to another. What we call nothing may simply be the space where the next note will be played. As you imagine this infinite garden, universes blooming like stars in a night without horizon, you might sense something familiar. Every breath of wind, every thought that rises and fades, every dream that begins just as another ends, all are small reflections of that boundless creativity. The multiverse is not somewhere else. It is the nature of everything, unfolding, renewing, forever alive. But even in an infinite field, there may be mysteries deeper still. Because if universes can be born, could they also be born from something? Could each blossom in the garden have roots, places where creation folds inward before it blooms again? Some physicists think they might, that every black hole in our universe could be the seed of another. And so, from this endless garden of worlds, our story now turns toward those darker roots, the places where light itself bends inward, and where, perhaps, another cosmos begins to grow. From the infinite garden of universes, our path now bends inward, into the dark, quiet chambers of gravity itself. If creation blooms outward in the light, it also deepens inward into shadow. The two have always belonged to each other. Every star that shines eventually collapses. Every birth carries within it the promise of return. And perhaps in ways both strange and elegant, the universe uses these collapses to plant new seeds of creation. When a massive star reaches the end of its life, its fire burns through the last of its fuel. With no pressure left to resist its own weight, it folds inward. The collapse happens so quickly that not even light can escape. What remains is a black hole, a region of space where gravity is so strong that all paths curve back on themselves. It is as if the fabric of the universe has bent inward to hide something from view. To the outside, it appears silent and final, a point of no return. But some physicists have begun to wonder if that silence might conceal a beginning rather than an ending. You can think of a black hole as a kind of doorway, not a tunnel to somewhere else in space, but a passage in the fabric of reality itself. Inside, matter doesn't simply vanish. It becomes compressed, its energy and information stored in ways we still don't fully understand. Theories suggest that as matter collapses into extreme density, the usual laws of physics, the ones that describe distance, time, and light, begin to blur. And in that blurring, something unexpected could happen. The formation of a new universe. It's a beautiful inversion. What looks like destruction from one side might be creation from the other. Imagine a star dying here, while, behind the curtain of its collapse, an entire cosmos bursts outward. To us, it would appear as a black hole, a void that swallows everything. But to an observer on the other side, It might look like a big bang, a moment of light and expansion, death and birth, woven together through the same event. The idea is sometimes called cosmic rebirth through black holes, and it comes from attempts to unify the physics of the very large, gravity, with the physics of the very small, quantum mechanics. If space and time are not continuous but composed of discrete elements, like the threads of a finely woven cloth, then under extreme pressure they may not tear but reform, reweaving themselves into something new. In that sense, every black hole could be a seed, a tiny knot where the universe folds inward and then unfurls again somewhere beyond our reach. We can't see this process, of course. The inside of a black hole is sealed away by what scientists call the event horizon, the boundary beyond which information cannot return. But the mathematics that describe black holes are eerily similar to those that describe the early universe. Both involve extreme density, intense curvature of space, and energy compressed into forms we can barely imagine. It's as if every black hole is a small echo of the universe's own birth, a reminder that creation and collapse are not opposites, but reflections. Stephen Hawking once compared this relationship to the turning of pages in a book. From one side you see the words, the story, unfolding, full of light and motion. But when the page turns, the previous story disappears, making room for a new one. The book never ends, only changes chapters. Perhaps black holes are the universe's way of turning pages, the past folding into itself, giving rise to another beginning written in another script. There's an emotional symmetry to it too. Every human life, every cycle of nature mirrors this rhythm, endings that lead to beginnings. A tree drops its seeds only as its leaves fall. The night sky, for all its darkness, is filled with light from stars that have already died. Their passing gives rise to the elements that build new worlds: carbon, oxygen, iron. Even your body carries the ashes of ancient suns, atoms once forged in explosions, later recycled through time. Creation and destruction are two hands shaping the same clay. If black holes truly give birth to new universes, then every collapse we witness is a whisper of eternity renewing itself. Somewhere beyond that invisible horizon, time could begin anew, space could stretch again, and perhaps new stars could rise under different laws of nature. Each black hole could be the womb of another reality, each with its own constants, its own possibilities, its own storytellers wondering where it all began. In that view, our universe might not be the first nor the last. It could be one in a vast lineage, a cosmic ancestry stretching back through countless generations of stars and collapses. Just as we're born from those who came before us, perhaps our universe too was born from the death of another. The parent universe may have collapsed long ago, its black holes becoming the seeds of our own space and time. We are in that sense the grandchildren of collapse, life emerging from the ashes of another cosmos. And if that's true, then even the end of our universe will not be final. Its black holes, scattered like dark pearls across the cosmic sea, will continue to gather matter and light, growing heavier and denser. Each will eventually reach the point where it can no longer contain itself. When that moment comes, maybe the fabric will twist again, and from within its darkness another universe will unfold. New laws, new stars, new stories. The idea that every death creates a beginning may sound poetic, but it's also profoundly physical. Energy never disappears, it only changes form. The same rule might hold for existence itself. The universe, like a tree, returns its nutrients to the soil from which new growth will rise. The cycle continues, not because it must, but because it can. So when you look up at the night sky and see a region where no light escapes, don't think of it as a void, think of it as a promise. Behind that darkness, space may already be blooming into something we can't yet see, a new dawn waiting in the folds of the present. From this realization comes a quiet peace. The edge of the universe, the place where everything seems to stop, might not be a wall at all. It might be the backside of a beginning, a place where the cosmos, having learned the art of renewal, writes the next chapter of itself. And so, as we drift toward the final part of our journey, we carry this thought with us. What lies beyond the edge may not be distance, but transformation. Perhaps every collapse is simply the universe taking a deep breath, preparing once again to begin. And now, after our long drift through light and shadow, we arrive at the quiet edge of everything. Not an ending, but a soft horizon where the known world begins to blur into possibility. It feels like standing on the shoreline of existence, watching the waves of time recede and return. The sky above is not dark but deep, and beneath that depth, you can almost hear the hum of something endless, the pulse that started it all, still beating, still waiting to begin again. We've travelled from the smallest particles to the grandest galaxies, from the first breath of creation to the imagined rebirths that might follow. We've wandered through the quiet geometry of voids, through horizons that stretch faster than light, through moments where time itself trembles and becomes soft. And all along, the universe has shown us the same secret again and again, that everything we call an end is also a beginning wearing a different face. You might remember the first questions we asked. What lies beyond the edge of the universe? What happens after the last star fades? Where does time go when there's nothing left to measure? The answers, as we've seen, are not final lines but folds, gentle curves in a story that circles back upon itself. The universe doesn't break. It bends, it loops, it remembers. Think of horizons. We once thought they were limits, the place where sight stopped, where knowledge failed. But in truth, a horizon is never fixed. As you move toward it, it moves too. You never reach it because it is not a boundary. It is an invitation. The same is true of the universe's edge. There is no wall, no end of the map marked, "Here be nothing." Beyond every horizon lies another, and beyond that, another still. Each one a new way for reality to express itself. Perhaps what lies beyond the observable universe is not a region, but a renewal. The point where the old laws make room for new ones, where time folds back into its own beginnings. Maybe the end of this cosmos is simply the underside of another, like the inner surface of a great wave. When it crashes, it does not vanish. It rolls back and rises again, carrying all its fragments into motion once more. If we could step outside time for even a moment, perhaps we would see it all at once. Every expansion, every collapse, every cycle of creation stacked like pages in an unending book. The chapters would not follow one another in order, but would coexist side by side, folded together like the layers of a seashell. We would see that there was never truly a first or last, only motion, endless, graceful motion. And in that motion, we would see ourselves, because we are not separate from the universe's story. We are threads in its tapestry, woven from the same fibres that stretch across galaxies and through atoms. The carbon in your breath was born in a dying star. The warmth in your skin was once light that wandered for billions of years. You are the cosmos, gathered for a moment into thought, into awareness, into wonder. You're the universe looking back at itself, seeing its own reflection in the surface of time. When you realise that, the idea of edges begins to fade. The boundaries between you and everything else soften until they almost disappear. The air you breathe, the starlight that reaches your eyes, the atoms in your bones, they're all shared, all part of the same flow. You're not in the universe, you're the universe, briefly awake. Even death, in this view, becomes less frightening. It is not the opposite of life, but its continuation through another form. Just as the universe folds inward to create new beginnings, each life folds into the greater story of existence, returning its energy, its atoms, its memories to the whole. Every ending of a star, a thought, a person, a world, adds another layer to the spiral of being, Nothing is ever lost. It only changes rhythm. Maybe that's the truest meaning of what lies beyond the edge. Not distance, not another place, but transformation. The universe has no edge in space because it has no edge in meaning. It is a song that never stops playing, only changing keys. When you look up at the night sky, you're seeing across time. Some of those stars no longer exist, their light still travelling toward us long after they've gone dark. And yet, they are here. Their light still touching our world, their presence still felt. In that sense, the universe itself remembers. It carries everything forward, turning even absence into memory, silence into rhythm. Maybe that's why we find peace in the vastness of the cosmos. Because deep down we recognize the pattern, not intellectually but instinctively. We feel it in the beating of our hearts, in the rise and fall of our breath, in the tides and the turning of seasons. We live within the same rhythm that governs galaxies. The universe breathes through us, and we breathe it back. And so, the edge of the universe isn't something to fear or to reach. It's something to rest in, to trust that wherever the horizon bends, it bends toward continuation, toward new forms of beauty, new stories, new dawns. The cosmos, like us, is learning how to begin again, endlessly. If you listen closely now, beneath the quiet hum of your thoughts, you might hear it. The faint pulse of everything, still beating, still moving, still whispering that there is no final silence, only rest before another awakening. The stars, the voids, the shadows, the beginnings, all part of one unbroken breath. So perhaps the greatest secret of all is this: the universe has no edge, only folds. Folds where it learns to start anew, folds where it pauses to breathe, folds where it remembers what it once was and what it will be again. You, too, are one of those folds, a brief, luminous curve in the fabric of time, part of the same rhythm, the same infinite dance. And as our journey comes to rest, feel the stillness of that truth settle around you like soft starlight. You're not drifting away from the universe. You're floating within its heartbeat. Its light lives in you, and your quiet wonder lives in it. Every thought you have, every dream you carry, is part of its unfolding. And so, we've reached the end of tonight's exploration. Whether your eyes are still open, or you've already begun to drift into dreams, thank you for travelling this path through beginnings, endings, and all the silences in between. If you found calm here, let it stay with you as you sleep. If questions linger, let them rest. The universe is patient. It will wait for you in the next dawn, and the one after that. For now, may your mind be light, your breath steady, your body at peace. The cosmos is still unfolding, and so are you. Sleep well, traveller among the stars.